All right, welcome to week 25 of STEM Engineers. We've been studying various African American engineers over the past month. Today is no different. This week we are studying how Dr. Mark Dean invented the isobus, which allowed peripherals to be plugged into the computer. Watch the video, review the slides, and then take the quiz on the final slide until you get 100%. 100% is the same as 7 out of 7. This is the final slide. A lot of information for this slideshow comes from and is quoted from this specific link to a podcast on YouTube. The engineering method. We want to define the problem, do your research, develop a possible solution, design your solution, build a prototype, test it, evaluate your solutions. Guys, this process is so cool. It was used by Dr. Mark Dean, maybe not specifically in the exact steps that we're going to show, but we can see these steps in the process. And that's what we're going to do today in Dr. Mark Dean's invention of the isobus. Problem: how to make the peripheral parts of a computer communicate. So he invents the isobus, was the translator that Dr. Mark Dean helped invent. It allowed all the plugins, screen, printer, etc. to be plugged into the computer. A computer peripheral is any external device that provides input and output for the computer. For example, a keyboard and mouse are input peripherals, while a monitor and printer are output peripherals. In the define the problem step, engineers decide exactly what issue they want to address. It could be as simple as removing a stain or as complex as reducing global warming, but it must be specific. The objective when IBM got into personal computers in the 1980s was to build something smaller than a refrigerator that you could plug into at home. It was not an obvious fit for IBM, who normally made mainframes, which were enormous and cost millions of dollars. But the integrated circuit made computers potentially much smaller. So their objective was to make something smaller than a computer. I have a picture of a mainframe, one of the kind of things that they made back in the 1980s when their personal computer first was getting developed. And it's huge. IBM made their project to deliver a PC in 1 year. They called it Project Chess. Towards this goal, they assembled a team of elite engineers. So if I said, what was the specific problem that IBM was looking to address? They wanted to make a PC in 1 year. And they called this Project Chess. To understand how big the project was, data scientist Tony Hay explains they had only just got past the stage where they introduce separate hardware and software. So this is a very difficult idea and concept to start to get into. PCs really weren't there yet. And by the way, this little sidebar goes through the steps of the engineering process and allows you to go ahead and see exactly what step we're talking about on the slide, and also navigate. So I'm going to navigate to the next step. Doing your research is a critical step. It allows you to learn from hundreds of others' experiences rather than trying to discover everything on your own. So if when you were born you had to discover everything on your own and you did not have the chance to go to school, learn, go to the library, talk to friends, family about how to do things, you would spend a lot of time discovering things. Even something as simple as gravity. Imagine you never were taught about that. Maybe you'd figure it out on your own. You probably would. But probably not to the extent that, definitely not to the extent that it's been researched, because hundreds of others have studied it. So IBM knows this. So what they do to research, quote unquote, is they assemble a team of 12 people to do this. And on this team was Dr. Mark Dean, who had a background in architecture, not the house kind for computers. This knowledge base would help him design the isobus. ISA stands for Industry Standard Architecture. It also stands for a lot of other things, so we need to be specific when we talk about computers. This chip needed to be a translator so that all the parts of a computer could be connected. So we have a picture of an isobus down there. We have a picture of Dr. Mark Dean holding, I don't know exactly what computer part he's holding. Then they have Dave Radley, who works on the interface, working on the BIOS or interface to the software. We have other people working on the box and how it's going to be held inside there. But they're doing their research. They threw 12 people, 12 experts together rather than going to the library or doing whatever else. They had experts who kind of already had a lot of knowledge working together. These experts, they develop a possible solution. It's a brainstorming phase. In this step, if you skip this step and design the first solution that comes to your head, if you skip from doing research to design your solution, you might skip over a better solution. Think of as many solutions as you can and write them down. And this is interesting in the problems that I've given in STEM projects in the past. You guys all come up with different solutions. And if we were in a class together, what we do is we put those solutions on the board and we would discuss what the best solution was, which is what these 12 people got to do. These 12 engineers and programmers picked by IBM to complete Project Chess tackled the problem from multiple angles. They had to work together to develop a solution. Let's skip down here. They had a new problem. These elements were not designed to communicate with each other. If Project Chess was ever going to succeed, they would need something that would work as a translator. So IBM's mission is to create a personal computer. Mark Dean's mission becomes to solve the problem of how to get all these parts to work together, because they don't have enough time to make all of their parts just amongst 12 of them. So what they decide to do is they decide to get parts from different companies and put them together into their computer to work with the other parts that they're going to develop. And they know to do this, they need a translator. Designing your solution is the step to get critical between the previous step and this step. You want to choose your solution and then refine it. How exactly is it going to be made and work? If Project Chess was ever going to succeed, they would need something that would work as a translator. That's what they're going to do. Specifically, that's what Dr. Mark Dean was going to take on the problem of making a translator that could allow all the different parts of the computer to communicate. By solving this problem, he would create a whole philosophy of computer design. So the philosophy being that now you could take different parts from different places and put them together. To allow for scaling and peripherals at a never-before attempted level, Dr. Mark Dean needed to build what we now call an industry standard architecture, or ISA bus, that would let expansion cards connect to the computer's motherboard. The bus would be a translator between all those off-the-shelf components they had to use. So this is a picture of all the peripherals in a computer and the computer itself. Build a prototype is when you build a model that shows what the actual invention can do. It also helps you learn about the invention before you actually build it. Dr. Mark Dean and Dennis Muller's first ISA bus would be upgraded continuously to make it better in years to come. So Dennis Muller, working with Dr. Mark Dean, invented the ISA bus on the team of 12 engineers. Dennis Muller developed the ISA bus with Mark Dean. Back then, they were calling it the PC bus. A later version would be called the AT bus, and then still later, the ISA bus. This PC bus was done in such a way that anything developed for the PC should be able to be reused, and with the added performance features, you should be able to do more powerful add-ons. What they made in 1981 was an entry-level machine with 16 kilobytes of memory. So here they are, they're building their first one, they put it on the market, and then in the future years, they come out with better ones, because they keep going back and they build a prototype, they tested it, they validated the solutions, and then they went back, did more research, and it kept getting better. And part of the thing that helped get it better was, well, we'll find out. Testing your invention or solution to the problem is important. IBM would print out a manual to their product and build better, more powerful versions each year. So IBM not only works on their product, but then they print a manual to the product so that other people and the public, anyone, could see exactly how their computer works and all the specs and specifics of the computer. And this allowed a lot of people to work on the design. Remember back in Develop a Possible Solution, when we talked about how important it was for a whole group to suggest answers and then to think through and come up with the best? Well, by producing a manual, everyone in the world, if they wanted, could work on this and work towards a better, faster computer. And that's what starts happening. Original PC had an 8-bit bus. Next Gen had more complex 16-bit bus to expose more of what it could do and allow more add-on devices. Basically made a superset of the 8-bit bus, which was 16-bit, and spent a lot of time to ensure compatibility. So what that's saying is it made the isobus more powerful and faster, or more powerful and able to store more information, allowing a whole industry to supply parts and software for the IBM PC had one other effect too. In order to have that kind of modular architecture, modular means you can like swap it out this for that and put these 5 pieces together instead of those 5. You have to have an open architecture. The machine's information was printed out in a manual and handed to the public. And that's kind of how they tested it. They put it in the eyes of the public, and then they kept coming up with better solutions, or better versions rather. Evaluating your solution is when you question everything. Does the invention solve the original problem? How well does it work? Could it work better? What about it does not work? And all these companies begin to continuously answer this question because the invention of the isobus kind of kicks off the PC age. With all these companies getting in on building better, different parts, because now they can all communicate. All right, this is a quote by Mark Dean. It says, "You need to do things in the open. You need to build an industry to build a greater opportunity. You can have a priority design and own the entire market, but the entire market would be small. Let people play and let them grow the market, and then you have a bigger pond to swim in, and you just go after that bigger opportunity." So this is just saying that you could, have like priority design means you have the kind of rights to the design. So you know the solution. And no one else does, and you kind of keep that a secret. They don't print out the manual; they keep it a secret, and then everyone has to buy from you. Or you could tell everyone about it, and all of a sudden, the technology gets way better, way faster because everyone starts working on it. But that means that you aren't necessarily getting all the money for it. So what you then have to do, and what you then get to do, is you go after the bigger opportunity. You notice where there's a new kind of option and ability and chance to do something new in the market, and you go after that instead of just constantly selling your first design. And we can all be thankful that they did that, because now we get to enjoy better technology like all the time at a super fast rate. All right, so that is the engineering design process. That was Dr. Mark Dean inventing the isobus, and that was IBM working on their first personal computer. Now we got a quiz on Dr. Mark Dean. You must get 100% to pass. You need to retake it until you get 7 out of 7 or 100%. I hope you enjoyed this. I got a lot of the information from the internet, believe it or not, and also specifically from this podcast, which you can click here and listen to the entire podcast if you are interested in learning more and getting more specifics on that. My Zoom office hours, go there as whenever you want to. From 2:30 to 3:30 is when I'll be on there. So that's when you should go there, and I would be more than happy to help you with any STEM work or questions that you have. All right, other than that, have a great week.